Welcome to all. Today we are going to discuss about filter design analysis tool by using MATLAB software. In command window, you type the command filter designer. Now it's initializing the filter designer. Here we already discussed in PPT session. Here there are current file information is there. Here filter specification. Here you can select the response type. It may be low pass, raised cosine, off band low pass, Nyquist and inverse sync low pass, and high pass filter also off band high pass and inverse sync high pass, and band pass or band stop, or differentiated type multi-band or Hilbert transformer, or arbitrary magnitude, arbitrary group delay, peaking and notching type. And also some design methods are there. It may be FAR filter or IR filter. If it is IR filter means Butterworth filter is a Chebyshev type 1, 2, elliptic type, maximally flat, and some more options are there. Here for example FAR filter means the equiripple or least square and window method. Once you select the FAR filter method means you can specify the filter order also there. Here also you can give the specification of filter order. Here density factor we have to enter. And for example now we are going to design, for example, band pass filter means you automatically choose the stop band frequency. You have to enter the stop band frequency, part band frequency, and also there. If you select band stop means here also it will change. You can see the frequency specification. Once you design low pass filter means it having only sampling frequency and pass band and stop band frequency. If it is high pass filter means here also you have to give the magnitude specification at the stop band or stop band frequency. And if it is differentiator means you have to give the vector format, that is both frequency and magnitude specification. You have to give the frequency specification model normalized 0 to 1, or you can select the frequency units. Here you have to give the frequency as a vector frequency and magnitude as a vector format. Once you select set the response type and the design method and filter order. Also you can see the filter specification block, that is your magnitude versus frequency or angular frequency and all things you can see. Once you click design filter, automatically filter will design without having any programming knowledge. You can directly see the analysis of your design filter. For example, I am generating, that is a band stop, that is FAR equiripple band stop filter. Here already these are some predefined values is there. So what is the pass band frequency, what is your sampling frequency, you can see. Now here some more options are there. In file option, you can import the filter coefficient file to your MATLAB workspace to import filters from Xilinx coefficient file, and also you can export option is there. Also export the filter design into Simulink model, and also you can export some options are available here. If you click export, here option export to workspace or coefficient file or MATLAB file or SP tool is nothing but signal processing tool. And also export is in the form of coefficient or objects or system objects, you can export. Also you can generate the MATLAB code by using filters function or filter design function or data filtering function. There are some more options are available. Depending upon your requirement, you can generate the MATLAB code with this function or without function. And the next one is the edit window is there. Convert structure, you can convert the form, that is your filter structure is a direct form. FAR filter means you can change the structure into direct transpose form, and any type of lattice form, any type of filter structure you can convert. This is a important tab called the analysis tab. If you design filter, you can see the filter specification, magnitude response, phase response, magnitude and phase response, group delay response, phase delay. There is so many analysis options are available here. Also overlay analysis also there. Analysis parameters also you can give, and sampling frequency also set. Just next one is a target window. Even by, you can generate, that is a export, another way of exporting form, that is you can generate CADR file, you can generate Xilinx file, Xilinx COE file, you can generate VHDL or Verilog file, you can generate for digital signal processing boards. There is a Code Composer Studio software is nothing but to simulate the digital signal processor. So view icon, this is for you can see the analysis by using grid or legend. You can select, this is for view method, this is a window method. And also once this is a, my aim is FAR equal band stop filter, is a filter order already given here, you can see. Now design filter, here you can see the magnitude response type, magnitude file. Here for example I am going to see the filter specifications block, and the next one is phase response, and the next one magnitude and phase response. Then lot of available options are there. Without writing any program, or without writing any functions using, directly you can see the frequency as magnitude curve, and also along with the phase response you can see. Here itself you can change the type of the filter response type. Here I am choosing band stop filter, band pass filter. Now click design filter, you can change the view here. For example you want to see the filter specifications, also it also changes this one. Once you click the go to analysis window, and filter visualization tool, you can click here. Directly your magnitude response is coming like this. You can this is by using data pointer. Once you click on the response, you can see the frequency response, at what points your frequency and magnitude. Also you can refer by using this one. Also your alignment is there, font size, it is movable or and interpolation method, and export the cursor to workspace. You can see also you can export the cursor data to your MATLAB workspace file. This is an important tool, that is called filter visualization tool. Here there are some options are available here. By using this filter design, you can create a multi-rate filter. Here you view the type of the filter. Type is my type of the multi-rate filter as interpolator, decimeter, fractional rate converter, use like current FAR filter, use default Nyquist filter. Also there are some more options are there. Interpolation factor you have to give, and what is the sampling frequency. Once you set the types, create multi-rate filter means you can create the multi-rate filter option. And the next one is transform filter. You can filter response type as you can transform into there is a original type is low pass filter. You can change the values, low pass, FAR, or narrow band or wide band or complex. Any type you can transform. This is the next option. Third one is, it is a loading filter quantization panel. You can quantize the filter. This is a filter arithmetic. There are previous one designed one is a double precision floating point and single precision. You can convert into fixed point. You can choose. There are additional settings are also there for that this quantization level. Here you can set the additional settings. For example, if I choose a fixed point, you have to set the filter precision. You can select specify all, and also input and output. You can give the fraction, input fraction length, and input output wavelength. Also you can give. Here rounding mode is, you can select any type of rounding mode you can select, and overflow mode you can select any one. Now click apply means you are quantizing the filter process is over. Similarly you can realize the model. That is a here also some block name, current method, filter designing method. You can say here also you can realize the filter optimization block. This block is for optimization. Next one is a pole zero editor. By using this response, these are all the poles, these are all zeros. Here coordinates are there. That is a polar rectangular plot is there. Here you can select the conjugate option. Now you can vary the zeros point. You see the response of the filter. Once you align the, you can see the response type, that is a filter one, quantized, and a reference one. Once you change the you can add the, this is option to add the poles, this is option to add the zeros, and this is a delete pole zero plots, and move your poles and zeros by using this cursor. You can change the poles and zeros position. You want to optimize the filter response on the filter this one. Next, import from workspace. We can import the filter coefficient from MATLAB workspace, and this is the filter design option. This option is there, the design filter option. Now we can see the how to generate MATLAB code. By using this filter design and analysis tool, is a band stop and band context and reference also there. Now you can check the analysis block here. You can see the phase response and all things. Now you are change this one. Here also you are converting the filter structure and pole zero plots. This is the pole zero. Then target, you can generate the C header file here. Here generate C header file means here you export the data type to your export menu. Fractional length you have to give, or if you can select the signed 32-bit integer or signed 16-bit integer, any type of you can generate. Here I am choosing what is the header file, C header file. You can C file, click save. Now you can see the C file for decide filter. This is the C program file for a discrete time FAR filter. This is a filter structure is a direct form, and what is arithmetic, fixed arithmetic, it is fixed. You can see the filter coefficients, and similarly you can generate the Xilinx coefficient file. Here also where I am storing here Xilinx coefficient untitled one. Save as type is COE file. This is a Xilinx core generator file for your descent filter. Similarly you can generate HDL file. Here you see C file is generated here, and then you can choose the target language as VHDL or Verilog. First I am choosing VHDL file. That is you can give the file name and folder and generate MATLAB code also there. Here there are filter architecture, what is the internal processor interface, or you can choose the multiplayer CSD multiplayer or factored CSD, and global settings are there. In these global settings you can say view the file VHDL file extension and package postfix and clock real-time postfix. Also there some more options are there. Also you can generate the test bench for a particular VHDL file or Verilog file. The file name is filter.testbench file. Here for example you can see the simulation of impulse response, step response, and also some more important forms are there. Here you can choose the type, your direct form FAR filter order. Here if you click generate, you will get the generate HDL form. In command window you can see the, here you see the generating input stimulus, generate input stimulus settings, length 3149 samples, generating test bench file. This is for VHDL file for your decide filter. Here you can see the target language is VHDL test bench simulation is also there. You can see the type of the filter. This is a discrete time FAR filter. There is a really response arithmetic fixed, You see the header file for VHDL program, library IEEE, and package files also there by using function to integer target and return integer target, and the procedures also there. The detailed VHDL program is generated without having any additional features. And the next one is your target. Also you can select the model with Verilog model. Previous one we discussed about Verilog VHDL. Now you select generate MATLAB VHDL file. Here it also generating the input stimulus, and also there you see the extension here .v. This is a Verilog format. The previous one is .vhd. Here you can see the model filter design, that is HDL code generation options. Target language is Verilog. You can see the direct form FAR filter, and the specification is there. You can see the header file for Verilog filter, that is a model. It contains module, and it starts with function, and the format is by using the filter design. Task format is there, and then the signal generation. You can see the Verilog program. And the next target is that is a code composer studio file. By using the you have to connect the DSP port to your PC, then only it asks. Here also export form mode is C header file or write directly method, memory method, and also you can select the export data types as the integer type, signed or unsigned integer, or double precision floating method or single precision floating method. You can select here. Next one, you have to select the target. If you select the target, you can generate the code composer studio, that is IDE file directly. So these are the main important features available in MATLAB. And also some option is there. Export file into your Simlink model. Here you can directly export your filter design to Simlink model. Here there are options are available to destination option, current, new, and user defined function. You can generate the filter block input processing as frame based or sample based. Anywhere any type you can select for input processing, and optimization also there. Here if you click realize model, it takes some times to generate. It takes some times to generate a Simlink file. For example, once you write the program to in your option, you can directly get the Simlink file. If the realizing model is going on, this in the realizing model you can see the Simlink file. Here now you see the input and output block of your desired filter. Once you click on the input and output model, you can see the Simlink file. Here you can see the input quantizer and filter option is there. You can see the filter version of the input quantizer. If you click on double click on that, you can see the block parameters input quantizer option. Here this is the filter option is there. Here you can see the block filter parameters of the filter. In this way you can generate script by MATLAB script file or Simlink model file by using this filter designer app. Here also one more important option, that is your filter visualization tool, and also some signal processing tools also available here. The filter signal processing tools. You can see the realizing the model. Here it may be polar or rectangular model, or also some more important tools are available here. Thank you very much.